Okay, so before we start the lecture today, let me just summarize with you the basic things, the most important things that we covered so far in the course. So we said there are four important quantities we need to understand. The first one is the current I. So in I, which is basically the dq by dt. And the unit for this is amp. We have the voltage, which is basically the dW with dQ, and the unit is volt. Then from these two quantities, the current and the volt, we have the power, which is equal to V times I, and V times I, the unit is watt. And then we will have the energy, which is the integration of the power dt with the unit is in joules. So these are the four basic things. We will work more on the current and the voltage, a little bit on the power, much less in the energy in this course. And then we developed what we call the passive convention. And we said if I have a circuit with a current enter the positive terminal, this is I and this is V, assuming the value of I and the value of B are both positive. If not, then we have to make them positive and do any necessary changes. So with this, we will have your P as positive value. And we say that because this is a passive convention, so the positive means the power is absorbed. On the other hand, if the current leaves the positive terminal, I leaves the positive terminal, then P will be negative, and we will say that the power is supplied, because this is against the convention. The convention is the passive, meaning the convention, the default that I'm absorbing energy, not delivering energy. So having said that, let's talk about all the components that we'll be dealing in this course. So the components are classified into two main things: active components and passive. Active means that the default of these elements that they will supply energy, and most of the time they will supply energy, but sometimes they will consume energy, and we'll see some examples of this. The passive elements, these are only to consume energy. They don't supply energy, which is the resistance here. The resistance will never ever supply energy. It just consumes the energy. And as we know that we cannot create energy from scratch. Energy goes from one form to another. So the energy consumes the electrical, sorry, the resistance consumes the electrical energy and convert it into heat. So the electrical energy is converted into heat when it goes through the resistance. Then we will have two components. We'll talk about them after the midterm. One is called the inductor and the other one is called the capacitor. These are also passive elements, but they have something special, not in the resistance, that they can be used to store energy. The resistance only consume energy. The L and the C can be used to store the energy, and later on can be used for some other applications. I will not talk about L and C now because we will not discuss them until the midterm. So let's go back now to my active elements, because the resistance is very simple and we'll talk about it a little bit later on. But these are the symbols of the sources. So basically we have two main types of sources of energy, either a volt source or a current source. A volt source means it supplies voltage, but also supplies current. And the current source, it supplies current but also supplies a voltage. So why we call this a voltage source and this a current source? If both of them can supply both quantities. The main thing here, when you say a voltage source, it means that the the voltage will be connected, will be supplied to the circuit, and then depends on the circuit, you will have a change in the current. But the voltage is the main thing, and it will be independent, as we will see, especially for the independent source, and vice versa for the current. Now, what I'd like to stress here is, now when you see plus minus, so it means this is a voltage source. When you see an arrow, it means this is a current source. Okay, so we understand now a voltage source, so it is mainly supplying voltage, but along with it comes the current. The current source with an arrow as the symbol, it supplies mainly current, but the voltage comes along with it. Now, what's the difference between the circle and the diamond? Okay, now in the voltage source as well as in the current source, there is something called independent source and dependent source. And this is what we want to mention in details in the coming slide. So before that, let's talk about the resistor, our passive element. So as I said, we'll talk about these elements only. We will not cover these two until after the midterm, so we'll talk about them later. So as I said, the resistor is basically a passive element. It only consumes energy, and the unit for that is ohm. Could be mega ohm. If it is capital M, it's mega ohm. Could be kilo ohm. If it's K kilo ohm, 10 to power 3, this is 10 to power 6. And the resistance here, and we will learn about this later on. If we have, and this is the symbol of the resistance, and if the current goes in this direction, the polarity that will be assigned will be plus and minus. And we'll talk about that later on, how to assign the polarity, because in this section we only dealing with elements with already pre-assigned polarity. But one of the things that you will see that whenever we have a resistance, and I will talk about that early next week, depend on the current direction you will have, the polarity will be assigned as such. And we'll talk about that later on. Now, there is something called the Ohm's law. And the Ohm's law is the law, this is the most basic law in electricity. It relates the three quantities. We have the voltage, the current, and we have the resistor. That the voltage, if you have put it in a pyramid shape like this will be the voltage, this will be the current, and this will be the resistance. So if I want to find the voltage, it is the current times the resistance. If I want to find the resistance, is the voltage divided by the current, and vice versa. If I want to find the current, is the voltage divided by the resistance. Now, since the resistance is basically a voltage by current, then the ohms is also volt per amp, because R is equal to V over I, and we know that the unit of the voltage is volt, the unit of the current is amp, so this is ohm. So the ohm is basically a voltage divided by amp. There is another quantity we rarely use it called the conductance. The conductance is the inverse of the resistance, and it's called G, and is equal to 1 over R. And in some cases we will not encounter much of them. We deal with it with the conductance. In some questions you might be given the conductance instead of the resistance, but not that frequently. The conductance unit is 1 over ohm. It used to be called mho in old books, but in the new books it's called the Siemens. Now, what is the resistance physically? If I give you a piece of wire and I ask you what is the resistance of this wire, basically the resistance is equal to rho L over A. If this is your wire, it has a length L, it has a cross-sectional area A, and it has a quantity called the resistivity. And this resistivity is a property of the material. So if we have conductors, this resistivity very, very, very small. If we have an insulator, this will be very, very, very high. And there is some materials in between. We call them semiconductor. So they are not conductors like copper or aluminum, and they are not insulators like ceramic or glass. They are something in between. And in this course, basically, we deal only with conductors. We deal with semiconductors or with insulators. Semiconductors used in electronics. Maybe some of you dealt with something called diode or transistor, but in this course, we will not cover that. So here, the resistance is equal to rho, the resistivity, times the length divided by A. And these will give you the factors that will influence the value of the resistance. So if we deal with conductor, this is a very small value, very, very small value. So this is why for the conductor, we have very small resistance. And in circuit, we assume it 0. We don't assume that there is any resistance for a wire. Although there is a resistance, this could be like 0.0001 ohm or something, very, very small value. But here it doesn't really, we will assume it equal to 0. Now, there are extremely two important cases or extreme cases in the resistance. One case when we have a short circuit, and the other case when we have an open circuit. A short circuit when we have the wire shorting 2 points in your circuit. So here you will see that in this short circuit, R is equal to 0, as we agreed. Now, when R is equal to 0, the voltage will become equal to 0. However, the current here, I, not necessarily equal to 0. The current actually sometimes becomes very high current, and we will understand later why is that, why the current becomes very high and it's not equal to 0. On the other hand, if I have a cut, open circuit means I have a cut. I open the circuit. So if I open the circuit, there will be no flow of electrons, because for the electrons to flow in a circuit, it needs a closed path. If I cut it, then there will be no flow. Like you have a pipe and you have water in the pipe. The water is the current. If you cut the pipe, there will be no continuous path of the water, and hence there will be no flow of current here in the circuit. Now, when we have an open circuit, the resistance called its value is infinity. Very, very high value. Assume it is equal to infinity. And the voltage here not necessarily equal to 0. In most of the cases, is not equal to 0. So what you need to know here, for a short circuit in your circuit, voltage across the short circuit, meaning between these 2 points, is equal to 0. So the voltage across this is equal to 0. But the current is not equal to 0. Here, on the other hand, the current is equal to 0, and the voltage doesn't equal to 0. And now let me throw to you my bonus question. We know that V is equal to IR. This is Ohm's law. Okay. Now, the question is the following. If the resistance here is equal to 0, so from this is basically V is equal to I times 0 equal to 0. This is why the voltage is equal to 0, regardless of the value of the current. Now, here we said that V is equal to, again, IR, and I here is equal to 0. So why the voltage is not equal to 0? According to the math, it should be equal to 0. So why it's not equal to 0? Let me see if you can have some explanation for this. This is just to challenge you a little bit. Because there is R which is not 0. Yeah, but I is equal to 0. Because R equal to infinity. Okay, so what? I need explain to me from the math, if possible. 0 times infinity is a special case. Yeah, yes, yes, yes. Here it is. Yes, you're right. Page. Let me see who is the first one to get the right, so that it'll be fair. I think because R equal to infinity, that was not, is a special because Page, Joyce. So we have actually Alexa and Page, you are there because R is infinity. So, okay, but still, so what? Even if R is equal to infinity, what does, why this is not equal to 0? Because voltage is only the potential difference. It exists. Okay, there is still a power supply. V equal to infinity is a number because the circuit still has a voltage. It just has no current. Okay, I'm really is it related to the limitation? The limit 0 times infinity. It approaches 0 in the denominator when it can use limit to see approach infinity. Okay. V is the difference. Okay. I think the closest answer, there is no 100%, but I think from all the answer, Grace Colin. Yeah, Grace Colin. I think your answer is the closest one. So please send me your ID after the class. Let me explain here. Why it is not equal to 0. Okay. So as I said, V equal to IR. Okay. Now, when R equal to 0, I, we don't know its value. So I is a variable times 0. So this is equal to 0. 0 times the number is equal to 0. Now, in the other case, V is equal to, the current is 0, but the resistance here, we know it's infinity. 0 times infinity, this is called undefined. Undefined. Okay, so the voltage here is not equal to 0. From the math perspective, cannot be, because 0 times infinity, this is called undefined. It could be any value. Okay, it's not a specific number, and that is what is happening, that the voltage can pick any value, and we'll talk about that later on. Let's see if there's a question here. Can you upload the annotated slides to G1 as well? Okay. You need the summary. Okay. Now, let's talk about the sources. Let's talk about the independent source. What's the difference between a dependent and independent source? These are two types of sources that we'll be using, DC and AC. And we talked about that at the beginning of this set of notes. We said that we will have AC and we will have DC. And the difference, the DC will have a constant value, but the AC will have an alternating. And we said we will not talk about this now. We'll talk about that after the midterm. So let's forget about that. Now we see here that the voltage, when I draw V versus I, this is I that the voltage supply can give. The voltage is constant. It doesn't change. Okay, so what does this mean? It means the following. Let's say I have a voltage source here, and let's say this is 12 volt. Okay, and let me have here 5 ohm, 2 ohm, 3 ohm, something like this. And then let me add something else, 4 ohm resistance. This 12 volt will stay as a 12 volt. It will not change. Regardless what you do in the circuit here, any alteration in the circuit will not affect this voltage source. So the word independent, it means that the supply will give you 12 volt regardless what you do in your circuit. Of course, That's sort of ideally, because in practical case that's not 100% true, but in this course we will stick to this definition. Okay, so that is an independent voltage source. It supplies you with the voltage assigned to it, regardless what you connect to that circuit. Now, except with this, and this is something you have to avoid, which is when you have a short circuit. We should not short circuit the voltage supply. And the reason is the following. We know that the short circuit voltage here, V is equal to 0. But the voltage also here is 12 volt. So between 2 points, we have 2 different voltages. A voltage equal to 0 and the voltage is equal to 12 volt. One of them will force the other to be to have this value. Of course, this cannot force this to be equal to 12 volt. So this short circuit will force the voltage supply to be equal to 0. How it will do that? By extracting, by taking the whole energy from the battery in terms of current. So you will have here a current with a very, very high value current. And this very high current will cause a lot of heat, because we understand now the electrical energy is consumed as a heat. So there will be a huge heat that can even burn the conductors. Okay, and yes, that is the reason why we have electrical fires. Electrical fires, the first reason for it is a short circuit. Whenever you have a short circuit in your system, then the current will become extremely high, and this will give you a very high amount of energy delivered, and this will cause burn. Let me just give you an example here. We know that V equal to IR, same back to Ohm's law. So I is equal to V over R. Now, if this is R, if you assume it is 0, so the voltage is 12 divided by 0, this is infinity. Of course, that's not 0. This is very, very, very small value. So the current becomes very, 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 very high value. The current very, very high value. The wire will not be able to handle this amount of heat, so it will burn. And as your colleague pointed out, that is cause number 1 for electrical fires, short circuit. And this is why in your house, there is a protection against this. Whenever there is a short circuit happened in your house by accident, then there will be something will trip. There is usually in your basement, there is a box where you will have, they look like switches. We call them circuit breakers. This one will trip whenever there's something like this happen. And then if you remove the cause of the problem and return back, it will give you back your electricity. This will trip means it will open circuit this. So this will open and there will be no flow of current. And this is protection. In every single house, you should have this. Let me see if here's some other question. So voltage gets converted to the energy, the whole energy converted into current, not the voltage. So a short circuit turns the wire in. No, the wire is a resistance, but with a very, very, very small value. Ideally, we call it equal to 0. Okay, so the wire, the current does not change the nature of the wire. The wire is a resistance, but with an extremely small value. And because it's a very extreme value, applying even a small voltage will lead to a very, very high current that can cause a lot of heat, because current is converted to heat, and then that can cause the fire. Now, let's talk about the other type of sources, which is called the dependent source or the controlled source. So this is a dependent voltage source. The previous one called independent voltage source. So both of them, they supply voltage, both of them. Their main thing is the voltage. But what is the difference? The difference is the following. We have in the dependent sources, there are two subtypes. Okay, I will slow down. We have two sources. First one is the independent voltage source, and we agreed that this source will supply energy, constant voltage, regardless what you do in your circuit. That is the first one. The second one, which is the dependent voltage source, will also supply voltage. But what is the difference between this one and the previous one is that this voltage is not an absolute value. This is a variable, meaning the voltage here is 2 times Vx. What is Vx? Is the voltage across another element. So depends on this Vx, this voltage source will give you energy. So if this is 10 volt, then this will become equal to 20 volt. It will give you 20 volt the supply. If this is only 5 volt, then this will give you only 10 volt. So this, although it's a voltage source, but depends on the voltage value in one of the elements, it will give you the amount of voltage. Or this voltage source can also depend on a current. And that's a point of sometimes confusing to the students. Yes, it depends on a current, but it is a voltage source. So the unit of this one still is a volt. Same here, it's a volt. Why? Because this is a voltage source. So it supplies voltage. Now, the element that it controls, this value could be a voltage or could be a current. So here, for example, if this is, let's say, 15 amps, this voltage source will give you 3 times 15, which is 45. 45 what? 45 volt. How do I know? Look to the symbol. Plus, minus, it means this is a voltage source. So regardless what the element, the variable that it depends on, still this will give you a voltage. And this is called dependent, or is also known as controlled voltage source. So this one we call it voltage controlled voltage source, because voltage controlled because the element that controls this is a voltage, and voltage source because at the end the quantity it supplies is a voltage. Here, current controlled voltage source. So the element that controls the magnitude is a current, but the value here it is a voltage. Okay. Let me see if you have any questions, because before, is the element controlling the voltage of the dependent always an independent? So no. These are voltages and currents in other, usually they are in resistors. They are not coming from another independent source. Their values is coming from a resistor. Now, let's ask ourselves one question. Physically, what is an independent voltage source? Independent, if I want to go to the market, what is an independent voltage source? The most basic one is the battery. The battery is an independent voltage source. So what is a dependent voltage source? A dependent voltage source, actually we use it only for modeling. They don't available as a physical device. We use them to model transistors and amplifiers. In this course, we will not deal with transistors, but we will deal with amplifiers. So these sources, you will see them when we model an amplifier. If I have an amplifier, I want to have a circuit to represent that amplifier, then we will use those dependent sources to have an equivalent circuit for the amplifier. But they don't exist as a physical device like the battery. And here is voltage controlled source. V is equal to K1 times Vx. Okay, now because this is a voltage controlled voltage source, K1 has no unit, because this is a volt and this is a volt. So if you multiply, this has to be unitless, otherwise you will altering the equation. Now for the current controlled source, V equal to K2 times I of X. So K2 is a gain parameter with the unit is ohms. because this is amp, so this has to be ohms to give you volt. So this has to be in ohms. Now let's go to the second source, which is the independent current source. Here, the source will give you current. And you can see here, as I said, there is also two types. There is current source DC and there is AC. We will not deal with AC now, which give you sinusoidal, but we'll deal only with DC. Okay. So here, if I want to draw the VI characteristic, the I will be, this one will give me 2 amps, regardless what is the voltage it supplies. Okay, there are some questions about here. The gain parameter is the quantity that is multiplied here by the variable. So how much gain you are getting. This could be 3, 5, 10. How much amplification you are getting from the original current. And sometimes it is attenuation, meaning it is less than 1. But most of the time it is an amplification. Let me see here if there is any other questions around. So for the voltage controlled source, the voltage is not an absolute value, whereas the other is no. Let me explain this. If I have a controlled source here, if I have a controlled source, and let's say this is equal to 5Vx, and I have here a resistance, a resistance, a resistance, another resistance. And this is, let's say, 1 ohm, 2 ohm, 4 ohm, 10 ohm. And this is your Vx. This is what controls this. So this Vx will have certain value. This voltage source will give you 5 times this value. Now, if I add another resistance here, let's say 20 ohm, this Vx will be changing, will not stay the same, because I'm altering the circuit, I'm changing the circuit, so this will be changing. So this now will not be the same as the previous one. You will have a different value, but it's again 5, which is the gain, times the variable, which is every time you change anything in the circuit, it will be changing. Now, compared to when I have 10 volt, 10 volt, regardless what you do the circuit, this will be always 10 volt. But this one will become, if Vx is 2 volt, this becomes 10. Then you do a change, any change in the circuit, this becomes maybe 3. So the voltage becomes 15. So this voltage always depends on that variable. What is the variable? Is this of that element? And then you will know what is the voltage. So that is basically what is dependent source means. Now, here I will go a bit fast because it repeats itself. This is the current source. So in the current source, basically, it's a current. How do I know this is a current? In the voltage source, it has plus, minus. So you have polarity. Here you have an arrow. Same thing for the independent. In the independent, you have an arrow. The other one, it will have plus, plus, minus. So this is voltage source, and this is current source. So it's very important to know the difference. So this is a current source. Again, the current source could depend on a voltage or it depends on a current. So this is voltage controlled current source. So it's a current source because there is an arrow here. However, the element that decide its value is a voltage. So depends on the voltage on this element, you will have a different current. So the unit here is in amps. Same thing here. This is a current controlled current source. So it's a current source, again, because of the arrow. However, it depends on IOI. IOI is the current that goes in this element. Now, depends on the value of this IOI, then you will have a different value of your current source. Now, again, we will have here the elements. I is equal to K3 times V. So K3 is equal to I over V. So it is amp over voltage, or it's the opposite of ohm, or the unit is the Siemens unit. And here I is equal to K times I. So this has to be, has no units. Now, we have two examples. Let's solve them before we conclude this. So here, Vs is equal to 2 volt. And this voltage source is 20 Vs. So the V0 is equal to 20 times Vs, which is 2. And this gives us 40 volt. Here, Is, so you can see here they are totally two separate circuits, and it could be, it doesn't have to be in the same circuit. So this is Is equal to 1 milliamps, and I0 is equal to 50 times Is, or it is 50 times Is value, which is the 1 milliamp, and this will give us 50 milliamps. Okay, so again, if Is for any reason changed to 2 milliamps, then your I0 now will give you a different current, which is 50 again times 2, which give you 100 milliamps. And every time this changed, then the I0 will be changing as well. Let's see this last example, and with this we will conclude our set of notes. Now we are giving 1, 2, 3 elements. So those elements are basically resistors, but we don't show them as the symbol. But we, starting from next week, you will not see something like this. You will see always like resistors. And then we will have a independent voltage source. How do you know that is independent? Because it gives you a value, 36 volt. So it's a number. Also, there is a circle here. So this is another way to tell that this is an independent voltage source. And then we have this diamond shape. So this is now a controlled. Now, is it a controlled, a voltage source, or it is a current source? Since it's plus minus, so this polarity tells me that this is a voltage source. And 1Ix, so the K is the, which is equal to the gain is equal to 1, and this is your Ix, and Ix is equal to 4. So basically the voltage here is equal to 1 times 4, which is equal to 4 volt. It depends on a current, but still it is a volt because it's a voltage source. So now we specified the values of, we know every voltage and every current here in this circuit. So we want to find the power absorbed or supplied by each element. So let's start with element 1. So P1 is equal to the current enter the positive terminal. So this becomes plus 4 times 12, which is equal to plus 48 watt. And we know that is absorbed. Let's go for P2 is equal to plus, the current is 2 and the voltage is 24. So this is again plus 48 watt, and again this is absorbed. P3, which is this one, the current is 2 amps and times 28, so it's plus 2 times 28, which is equal to plus 56 watt, and this is also absorbed. Now we have another power of the dependent source. So P of the dependent source will equal to the current, which is 2. Now this, the current leaves the positive terminal, so it has to be minus because this is now supplied. So minus 2 times the voltage here, we calculate that is equal to 1x. X is 4 amps, so this becomes 4 volts, so it's equal 4, which is equal to minus 8 watt. But this is now supplied because this is in minus. and the current leaves the positive terminal. Finally, P of the 36 is equal to minus the current, which is 4 times the 36, which is equal to minus 144 watt, and it is supplied. The last thing here, now we finished all the elements. We need to count how much power absorbed or how much power supplied. So you will find that both is equal to 152 watt here, and here is equal to minus 152 watt. So if you add, the total power will be equal to 0, because the power absorbed will cancel the power supplied. So let me see if you have any question, because we are done now. Okay. For control sources, can the source dependent or also dependent or on another source? No, it depends on a voltage on across an element. Could you go, will the total power? Yes, the total power has to be always equal to 0. Okay, Lisa, you said go back to example 7. I'm going back. Do you have any question here, Lisa? Any specific question? Why was P36 negative? This is in example 8. Because the current leaves the positive terminal. Okay, so if it leaves the positive terminal, it means it is supplied. If it is supplied, it has to be negative, because this is a passive convention. So the passive, you have two modes of operation. Active means you supply. Passive, you consume. So we say that we are using the passive convention. It means that the default that you are what? You are consuming. So if it is positive, it means you are in line with the convention. So your power is absorbed, so it's positive. So if the power is doing the opposite, meaning you're supplying, then we call this power is negative, because it's supplied and against the passive convention. So I hope that explains. Okay, so I will stop the recording.